Sometimes they're going to ask you to determine what type of equation you have. So in terms of types that we're going to refer to, it will be identity, conditional equation, or an inconsistent equation. Now, your book uses the word inconsistent. So some books will use the word contradiction. All right, so identity, conditional, inconsistent. So those are the three types that we need to talk about. All right, so we're going to come back to this sheet in a little while. All right, so let's go ahead and solve this equation. All right, so number one, we're going to solve each equation, and then you're going to classify the type of equation, and then classify the equation. Okay, number one, we have 2x minus 5x plus 2, in parentheses, equals 6 minus 2 times x plus 1. All right. Now, what kind of equation is this? Linear. All right. So how are you going to solve this linear equation? What are you going to do on the left side first? Distribute the negative 1. Good. So right now, remember that's understood to be a negative 1 right here. So if I distribute the negative 1, what do I get? Very good. 2x minus 5x minus 2. Okay. Now, on the other side, what am I supposed to do first on the other side? Distribute. Some of you are going to say 6 minus 2 is 4 and distribute a 4. You know you can't do that. The order of operations says I got to multiply before I do what? Subtract. So you multiply first, you distribute first. So it becomes 6 and then what? Minus 2x minus 2. All right. What's the next step that I need to do on each side? Combine like terms. So on the left side, what's 2x minus 5x? Minus 2. On the right side, what do I end up with? Okay, 4 minus 2x. Or you could say negative 2x and then what? Plus 4. Does not matter. Okay, so let's bring the variables to the right hand. I'm sorry, to the left. Let's bring it to the left so I can remind you about something. So if I bring it to the left, I'm going to add or subtract 2x from both sides. You're going to add 2x from both sides because right now I'm subtracting 2x. The opposite is 2. Add 2x. And then you combine like terms. What's a negative 3x and a positive 2x? Negative 1x or just negative x, right? Minus 2 equal, and what's left on the right? 4. Okay. What's the next step? Add 2. So I get, when I combine my terms, I get negative x equal 6. Nope. She said divide by 1. Nope. Negative 1, yes, negative 1. Because remember, negative x, there's no number there that's going to be a 1. So in this case, it's a negative 1. So this is a negative 1x equals 6. So if I want to get x by itself, which means positive 1x, then I need to somehow get rid of this negative 1 that's there. I need that to be a positive 1. So right now, I'm multiplying, right? X times negative 1. What's the opposite of multiply by negative 1? Divide by negative 1. And so negative 1 divided by negative 1 is 1. 1 times x is x. So what does x equal? Negative 6. Negative 6. Now, why isn't... Now this is still considered a rational equation even though you don't see any fractions. Because I can write my denominators as 2x over 1 and so on. They're all 1s. But why is it I didn't talk about restrictions? No, not because there's only one solution. Because why? I can't hear you. What?
She's saying no variable.
Yes, because there's no variable in the denominator, right? You only talk about restrictions if there are variables located where? In the denominator. Okay. So that's why I didn't talk about restrictions. All right, so I got a solution, right? I got a solution. So this equation is true only when x is what? Negative 6. So this equation is true only when x is negative 6. It's not true for any other number, right? So this equation is true only on the condition that x is what? Negative 6. So the only conditions in which this equation is true is when x is what? Negative 6. So which of these types of equations is the one that we just did? Conditional. Conditional. So identity, we're going to talk about this when we get to one. Identity, think of the word identical. So that's always true. Conditional is sometimes true. So listen to what I just said. This equation is true only when x is what? Negative 6. So if I plug in 5, is that going to be a solution? No. This equation is sometimes true. It's only true when x is what? Negative 6. All right, so this is a conditional equation. All right, conditional equation. Conditional, think condition. Only under the conditions that x is negative 6. All right, let's look at number 2. Number 2. All right, so this is my equation. What's the first step? Distribute. So I get 2x plus 10 minus 3 equal 2x minus 5, right? What's the next step? So I get 2x plus 7 equals 2x minus 5. Okay, let's bring all the variables one side, constant the other. So what's the next step? Subtract 2x. So when I subtract 2x, what do I end up with? 7 equal 8, negative 5. So notice that this is the first instance where the variable disappeared for you. The variable's gone, right? But then look at that statement that's left. 7 equal negative 5. Is that a true statement or a false statement? That's a false statement. 7 does not equal negative 5. That's a false statement. What that means is this now. What that means is that since I ended up with a false statement, 7 doesn't equal negative 5, that means that no matter what I plug in for x, it will never work. No, there are no solutions. No x will work. That's what that means. So in terms of solutions, there are no solution. No solution. And it kind of makes sense because watch. Watch at this part right here. See this line right here that I'm pointing to? I'm going to rewrite it. I'm going to rewrite this statement. So if x is 1, I want you to think about this. If x is 1, these two terms are identical, right? But is 1 plus 7, well, actually when x is 1, 2 times 1 is 2, right? Is 2 plus 7 the same as 2 minus 5? No. When x is 3, these two terms will be identical. You'll be left with whatever this is plus 7. Is that the same as this minus 5? No, check it. What's 2 times 3? 6 plus 7 is 13. What's 6 minus 5? 1. So does that work? No. No matter what you plug in for x, nothing works. Nothing will work. And it kind of makes sense because whatever I plug in for x, this term and this term are the same. So adding 7 and then subtracting 5 will not make it equal to each other. Yes?
Why didn't you just put like the like the 10 and the 3 on the other side.
The 10 and the 3 on the other side?
Like combine the like terms. Like
Okay, so I got
x.
7. What's your question? What about that 7?
I mean, like the 10 and the negative 3, why didn't you just put that on the other side?
Because it's on the left side. What do you mean by putting on the other side? Tell me
like
what. Tell me.
Combine like terms.
Okay, when I combine like terms, I get 7. 10 minus 3 is what? 7. That's combining like terms.
So you
Oh,
have to do
okay,
that
okay.
part first before you do that. So you need to-
Yeah.
He's trying to move the whole.
Oh, I wouldn't do that. You can easily mess up. I mean, you can subtract 10 from both sides, and you can add 3 to both sides if that's what you're asking. You can definitely do that. You can say subtract 10, subtract 10. Add 3, add 3. I'm not sure why you would want to do that. It's a lot more work.
It's a lot, yeah.
And you could easily have made a mistake. Okay? All right. Now, I want to say something else. Here's something else that people will do, and that's fine. See how I got to this point right here? And right away I knew that was a false statement. That's a false statement, right? Well, remember we solved the equation, we put all the variables one side, constants to the other? So if you want to go further, and you want to bring the constants to the other side, there's nothing wrong with that, but you could have stopped here because the variable went away. And what was that statement? True or false? False. So if you wanted to, you could have said, well, I'm going to subtract 7 from both sides. And this would be 0 equal what? Negative 12? But that's still a what? False statement. So there's no reason to go further with this. Once you get that false statement, you know there are what? No solution. No number works. And I tried to show you that no number works by just plugging in a few. Nothing will work. All right, that's still a false statement. So I would just stop here rather than bring all the variables from one side, constants to the other. So when I say false, I meant false statement. And then you say no solution. So in the blank, where it has x equal blank, what do you put? No solution. And then for classifying, let's talk about classifying. All right, so let's look at our 3 columns. There's one that's obvious to you what it is. Which one? Contradiction. Doesn't those 2 sides contradict each other? All right, so hence the word contradiction. So 7 does not equal 5. That's a contradiction. So this equation is a contradiction. Now, on my math lab and in this course, they don't use the word contradiction. They use the word inconsistent. So we're going to say this is an inconsistent equation. So this is inconsistent. So what kind of equation is this? This is an inconsistent equation. So inconsistent implying there's no solution. Okay, number 3. Suppose you had 4x minus 7 equal 4 times x minus 3 minus 3. What's the first step? Distribute on this side. So you get 4x minus 7 equal 4x minus 12 minus 3, right? So I get 4x minus 7 equals 4x minus 15. And then for some of you, you can stop here because some of you can notice this and see, well, the 4x are the same on both sides, but the constants are what? Different. So you know right away in terms of solutions, there's going to be how many solutions? None. There's going to be no solution. So you can go from here and say no solution. And so what kind of equation would this then be? But I want you to use what word? Inconsistent. I left the word contradiction on here because it's easy to notice that, hey, these statements contradict each other. So here's the word contradiction. But in this course, use the word inconsistent. Now, if you wanted to, you could have brought the variables one side. Let's do that. So subtract 4x from both sides. I get, and I combine like terms, I get a -7 equal a -15, and so that's a false statement. So hence the idea of that contradiction. But what if I changed this number 3 to this? What if I change it to this instead? So everything changed except at the end, instead of saying subtract 3, let's add 3. Let's see what happens. So same idea, you can distribute. So I get 4x minus 12 plus 3. The left side stays 4x minus 7. On the right side, though, what does that become? 4x minus 7. Right away, and we'll go further with it, but right away, what do you notice about both sides? They are, yes, that's the word I want you to use. They are identical.
Wait. 12 minus 3 is 9. That's -9.
Oh, crud. All right, thank you. So let's change this to a 9. Says me what? 9. All right, let's talk about this now. What do you notice about those equations? They're identical. They're identical, right? So if you could stop there, since they're identical, and notice that no matter what I plug into x, if x is 0, would 0 be a solution?
Yeah.
Yes, because what's 4 times 0? What's 4 times 0? And -9 equals what? If x is 1 a solution? Yes, because 4 times 1 is 4. 4 times 1 is 4. Aren't those the same? So in terms of solutions, how many solutions are there? 1. Who said 1?
Infinite.
It's an infinite number. It can be more than 1. I just mentioned 2 of them. So you know it can be 1. I would have been a little bit happy if you said 2. But there's an infinite number, right? This equation, those two sides are identical. Now let's go ahead, like we did these, and subtract 4x from both sides. And so I get -9 equals what? Which is what kind of statement? A true statement. Notice the variable goes away. So the variable goes away, you know one of two things now. You know that either you're going to say no solution, or you're going to say what?
True statement.
No solution, or a while ago I said this. How many solutions how many solutions are there? How many numbers can I plug in for x? An infinite number, right? All right, so in terms of an infinite number, you would say all real numbers. So I can plug any number for x, right? 5.6, is 5.6 a solution? Is 5.6 a solution, yes or no? I don't want you using a calculator. I want you to tell me, is it yes or no? But yes, because this side and this side are identical, so no matter what I plug in for x, the two sides are equal. If I plug in any fractions, same thing. This side equals that side. So that's a true statement. So in terms of solutions, if I have x equal blank, you're going to say all real numbers. Any number will be a solution. Any decimals, any integers, any fractions, rational numbers, irrational numbers. Any type of real number is a solution. Make sure you understand that. That's important. You got to look at this and actually understand why that's true. Because these two sides are equal. So what if I had this? Look, what if I had this? 4x minus 9 equals 3x minus 9. Oops. Yeah, that's fine. 4x minus 9 equals 3x minus 9. Will any real number work? No. Because I can actually get an x by itself, right? Because those two variable terms are not identical. Right? So if I subtract 3x from both sides, I get x minus 9 equals what? Negative 9. Add 9 to both sides. What's my solution? X equal what? 0. That's my solution. So you need to recognize, in this case, why this would be considered, the solutions are real numbers, why this here would be considered no solution, because look, 4x, 4x, the constants are different. 4x, 4x, the constants are the same. Here, the variable terms are different, so you are going to get a value for x. In this case, it's just 0. So let's check it. What's 4 times 0? 0 minus 9 is? Negative 9. What's 3 times 0? 0 minus 9 is? Left side equals the right side. So, going back to number 4, let's go ahead and classify this equation. Based on that table, what kind of equation do you think this is? Yep, identity. So identity. So that's an identity. So remember, an identity is always true. So this equation is true for any real number. Now notice though there is an asterisk right here where it says, remember we said all real numbers? There is an asterisk. If this equation had a variable in the denominator and this was still a true statement, we would say all real numbers except the restrictions. So I think we have one in a little while like that. So you'll see what that is. But you still say all real numbers. But if you do have any restrictions, you say all real numbers except 5. All real numbers except negative 2. The one over here, what kind of equation is this? No, but classified. Okay, let me rephrase it. Classify this equation. It is linear, yes. It is linear. Conditional. Conditional. All right, let's look at number 6. But yeah, you are right. It is linear. But I was wanting you to classify it. Okay, number 6. Suppose we had this. X divided by 2 minus 3/4 equals 10 minus 15x divided by 6. All right, so you have this rational equation. It's still rational, but even though there's just numbers in the denominator, it's still a rational equation. So since the denominators are all numbers, are you going to have any restrictions? No. So you only get restrictions if you have variables in the denominator.
That's 3 over 4?
Yeah, that's 3 over 4.
Oh, for 4. Okay.
That's a
Thought it
4.
was 6.
What's the LCD?
6. No, 12.
12. The LCD is 12. So remember we did last class period, we multiply all fractions by 12, the LCD. So we said this first fraction has to be multiplied by what? 12. Minus the second fraction has to be multiplied by what? 12. The fraction on the other side, 10 minus 15x over 6, has to be multiplied by what? 12. So everything has to be multiplied by 12. All right. Now let's reduce. 2 into 2 is 1. 2 into 12 is 6. Remember, the whole purpose of multiplying by the LCD is to get a 1 down there. So what do I end up with over here? 6x. Minus here, 4 to 4 is 1. 4 to 12 is 3. 3 times 3 is 9. Equal. All right, now be careful over here. Well, no, I would reduce first. 6 into 6 is 1. 6 into 12 is 2. Then, notice I put this parentheses because then you would have to distribute, right? All right. So what's 10 times 2? And what's negative 15x times 2? All right, so notice I did have to put that 10 minus 15x in parentheses because I had to distribute that 2. All right, we're almost done with that part. So then you subtract, let's add 30x to both sides. Add 30x to both sides. Yep. Equals 29. I'm sorry, 20. Then do what?
Then you're gonna add it. So 36x equals 29.
So it's x.
So 336.
So I get a solution, right?
Yes.
So what if you classified what is this classified as? Conditional. All right, let's do one more with this, and then we'll continue talking about quadratics. 8x divided by x plus 1 equals 4 minus 8 divided by x plus 1. So 8x divided by x plus 1 equals 4 minus 8 divided by x plus 1. Yes.
No, that's crazy.
Okay. All right, what's the LCD? X plus 1? So you multiply all three fractions by x plus 1. You're going to say the first fraction times x plus 1. The 4 times what?
X plus 1.
In parentheses, right?
Mm-hmm.
Okay. Minus, and then the third fraction times the LCD. Notice, if you want to put all those in parentheses like I did the x plus 1 over here, you can. Those that I'm pointing to are not necessary. This one is necessary. Because you have to distribute the 4 over here. So when I reduce, these x plus 1s divide out, what's left over here that I'm circling? 8x equal. Distribute, what do you get? For x plus 4, good. Reduce over here, what's left? Minus 8. Okay. Now, before I go on, we didn't indicate our restriction. What's our restriction? Okay, x cannot equal -1. That's the restriction. So I get 8x equal 4x
Plus 4.
minus 4. Then subtract 4x from both sides. I get 4x equals a -4, right?
And divide by 4.
Divide by 4.
X equals -1.
X equal -1. Okay? So that's a proposed solution, which you now know is an extraneous solution, correct? Because that's a restriction. So then you would say x equal, what's the solution? No solution. So this equation is never going to be true for any number, right?
Correct.
The original equation. So what kind of equation is this?
Inconsistent.
Inconsistent. So it's an inconsistent equation. All right. So that was the classification that I needed to get through. So identity is always true. A statement that's always true, identical on both sides. Conditional is sometimes true. So all the equations we dealt with the last week and the week before, those were conditional equations. And then contradiction would be never true. So inconsistent. So the equation has no solution. So this equation, now x equal -1 is not a contradiction. X does equal -1, by the way, for this equation. So that's not what I mean by contradiction. A contradiction would be something like we did earlier, where we had like -9 equal -7. That's a contradiction. But it's still this equation is still a contradiction or inconsistent because there is no solution. So we define a contradiction, inconsistent equation as an equation that has no solutions. Okay, so this had no solutions. Okay? All right, so that's number 7.